My name is Nicole Borman. Today is June 17th, 2020. In the fourth case study, the 2-month-old female would most likely be diagnosed with a glycogen storage disease. Specifically, type 2 von Gert disease, which we learned about through the lectures and in the textbook. This is also known as glucose 6-phosphatase deficiency. Glucose 6-phosphatase is used in both glycogenolysis and gluconeogenesis to convert glucose 6-phosphate back to free glucose to be used in the cells for fuel. The pathways of glycogenolysis and gluconeogenesis provide glucose for maintaining blood glucose levels during fasting. A deficiency in these pathways would cause hypoglycemia, which was a symptom. Epinephrine activates liver glycogenolysis. Having an increase in blood lactate rather than glucose shows a deficiency in that pathway, also present as one of the symptoms for the patient. This means that there could be an imbalance between oxygen demand and oxygen delivery to the tissues. Excess amounts of glycogen would be deposited in the liver, causing hepatomegaly, which was the big symptom in our patient. Hereditary fructose intolerance is a deficiency of aldolase B and presents with fasting hypoglycemia and vomiting. So although the patient did present with fasting hypoglycemia and hepatomegaly, she was not vomiting and there was no renal dysfunction present. Galactosemia is the absence of GALT activity, which causes an increase in galactose 1-phosphate. This is toxic to the liver, the kidneys, and central nervous system. It does present with cognitive impairment and failure to thrive in infancy. The patient was previously healthy and had no neurological signs. Glucose 6-phosphate dehydrogenase deficiency is an X-linked and more common in males. It presents with prolonged jaundice and anemia, neither of which were present in this patient. The diagnosis would most likely be glycogen storage disease type 2 von Gert disease for this patient. In the third case study, based on the low insulin levels, difficulty during infancy, and symptoms of PUPD or polyuria polydipsia, it is likely that this 5-year-old boy could be diagnosed with type 1 diabetes. Very low insulin is produced that normally transports glucose from the blood into the cells. With glucose being unable to enter the cell, it builds up in the blood, causing hyperglycemia, or high blood glucose. You can assume that the patient's fasted blood glucose would be highly above normal range, given that his insulin 1 hour after glucose loading was 5 compared to the normal range of 29 to 51. I also want to add that I see this a lot in practice in animals, although the interesting thing about this disease and these pathways is that it really does present similarly. Phosphofructokinase and pyruvate kinase are likely to be active in this patient. The reactions that take place in glycolysis by these enzymes are part of the 4 irreversible steps. These enzymes regulate glycolysis by acting as a catalyst for this pathway.